don't know about you, but this conference has always been about learning, that community, um, and about being inspired. And I don't know how you can't have all three of those things on many, many levels after seeing all the people that we've had speak. Um, and I will say, I think all of us here, especially you're here because you want to learn something new. And I've been thinking about recently, particularly with the rise of AI, is that you have to keep ahead of the robots. You don't want to be a function. Um, and I always feel like, you know, in order to stay above the curve, you have to continuously sort of disrupt yourself in many ways. And having this sort of wealth, knowledge, and I would say, uh, sort of thoughts, sort of aggregated in one place is really, really powerful. You'll walk away a different person today, in my opinion. And that's why we do this. So let me just start this. I'm going to talk about AI, but first, I want to talk about some of the images from earlier this week. If you were not there as part of the tech crawl or the tech um, um, tours, this is part of the tours. So Heatherwick, SLM, Thornton Tomasetti, we're part of this, as well as Big, and we have others. And so this was something we had new today, was the tours, or this week, I should say, to sort of connect the digital to the physical. And of course, this is one thing that you do get in New York City that I think you just walk around the corner. Well, across the street, actually, I was the engineer for that building. The tram was a Thornton Tomasetti project back in the 60s. So there's a lot of rich history here, and of course, Dave is like never ending. So we'll get to that. But it's been an amazing experience so far. It hasn't ended yet. So big, 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 big thanks to the organizers of this event, Dave and Giselle over there. So much work. So much curation. I didn't even want to think about it, but yeah, I mean, so much has gone into it, and we're not done yet. But I think they're starting to breathe. Just breathe. We're almost there. Big thanks to our crew of partners. I mean, so much people have contributed to this event. We're going to need a couple of different slides next year, I think, to cover everyone here, to even recognize all the people that have participated. So thanks to everyone who's participated in all those people that you see up there. It's pretty incredible. It's kind of who's who of our community. And of course, thanks for Speckle, who was the big contributor this year. If I knew that they were going to get a raise, maybe I would have asked for more. But no, I mean, it's glad to see. I knew Dimitri, I think, when he was a graduate student in Copenhagen, and so he was a young kid then, I would say, and to see it grow to what it is now is pretty cool. And of course, Luke Wilson's here as well, KPF. There he is right there. He sends a whole crew here, and so glad to have one of our trusted partners here, and of course Thornton Tomasetti, who allows us to do these things with very little oversight. I kind of do what I want to do, which is kind of great. But I will say, we do what we do because it makes business sense. That's it. You can't separate, in my mind, technology and business. It is one and the same. The day that I had a computer in front of my desk, which I'll talk about, which is 1997, was the day that technology and business became one thing. There's no separation. And the problem with our industry, I would say, a lot of people that are running the industry don't understand technology and don't know the power of it. So thanks to the speakers, big round of applause to all the incredible speakers that we had today. The nice thing about the speakers too is that it kind of sets a table for, and we don't plan this, sets a table for the presentation that I give. There's so many commonalities and so many sort of interconnections that of what we're doing as a community that it's pretty insane actually. So thanks to all the speakers. Announcement. So we will be participating along with the Shape to Fabrication Conference. We're going to tack on a hackathon to this in London in April. We're going to do it before the event, and there's some logistical reasons for that. It's going to partake at Forster and Partners office. They have a huge office in London. So definitely put that on your calendars. It's going to be fun. It's the first one hackathon as part of that event. So we'll see you in London. So, I will say, this year I was going to talk about digital delivery, and my team was like, "You got to go bigger than that. That's too tame." So I decided to go this direction, which I've been a big proponent of AI and machine learning, as I mentioned, since Dan introduced it to me in 2015. And I honestly think that it is going to be a big, significant technology that will save the people like yourselves who want to do something new every day, as opposed to the drudgery of doing repetitive things just to get something to show up on the screen or just to get a line on the drawing. That's not what we went to college for. That's not what we became engineers and architects for. So I want to thank, by the way, this is a Grasshopper script as well. By Nick Mundell made this Grasshopper script to make it clean instead of me like moving things around in PowerPoint. I want to thank the team, because this team inspires me every day. We have an incredible team all over the place, different continents. It's harder because we're larger now, so we have to sort of be a little more coordinated, I would say, but we don't want to lose the fun either of innovation. I'm going to talk about AI today, so I want to thank the AI team. Our newest member, who is Kohei Hayashi, he's on loan from the Shimizu Corporation. I have an incredible team here. Again, I get inspired every day about what they tell me. I just kind of say, "Is this possible?" And then they go back and they think about it, and a week later, there it is. So it makes my job easy in many ways. So I kind of just want to explain a little bit myself. By the way, my name is Rob Otani. I'm the CTO of Thornton Tomasetti, and I want to just explain that, and hopefully nobody does math really well in their head, but I graduated in civil engineering from Rutgers University in 1990. I worked for 2.5 years in a civil engineering company, didn't like it, went back to college, got my master's degree in structural engineering in 1995. So and then I joined Thornton Tomasetti. In 1995, we did not have computers at our desk. There were shared computers. The CAD people had computers, and we did half CAD, I would say, half hand drawing. And so I tell you that because, in my opinion, the biggest disruption in AEC was when we got computers. For 100 years, we were doing hand to paper. And all of a sudden, you had this thing that can do, really clean drawings. But I would say what was CAD, or honestly, even to BIM, it didn't improve the output. It just made it a little bit seemingly simpler, but it actually wasn't. And part of the reason of that is because the technology, particularly where we are now, if you use Revit, if you use, I'm a structural engineer, so we use CSI tools, all the S-Concrete and all these other crappy tools that are out there. They were made in the 90s. They haven't changed. Bentley, RAM. And so where we need to be in terms of what we produce and how we work is technology that was based in the 90s. So therefore, it's not aligned with what we do. Whereas when I started in 1995, it was very clear. The alignment of what we produced, what we needed to produce versus what clients were asking for was very clear. We had an optimized process over 100 years to get to where we were. So this is where we are, unfortunately. By the way, I'm a structural engineer first. I wouldn't call myself a technologist. I'm sort of a connector. I said this last year, and I still believe in it. I kind of want to talk about these things, and I wish there was a screen here. By the way, I'm one of these people that like to improve things all the time. I would improve that door. I would put a soundproof barrier over there, right? Anyway, I'm a little bit crazy there. So, as I mentioned, our most widely, and I put a screen, I have a screen there so I can see. So I can't see it, so I'm going to look back. Um, Let me just do it this way instead. So our most widely used software, BIM, is slow. It's super slow. I mean, compared to what we need it to do. It's built on 90s tech, as I mentioned. It has been developed for paper. So if you were to wake up today and say, I need to transfer the information of our ridiculous 3D models to the contractor for fabrication, would you then flatten it into symbols and lines onto a piece of paper to give for them to then rebuild it up in 3D? The answer is no way. So we're working towards a 1900 standard in 2024. Documentation is super slow. Access to this is another issue of our offices around the world, is that previous data is hard to find, so we just rebuild it every day. We redo it. And town is moving out of AEC. No question about it. So I'm gonna go through this quickly. The alignment of what we do is not in alignment to what the client needs. So because the software that we typically use is made for CDs, people do CDs at SD level. Chance of change, 100%. Similar to a design, you need to give a little more information, but still we're doing CDs at DD level. The DD stage, 50%. Now, I've been doing this for almost 30 years now. In the last 15, I have not had one single comment on my SD or DD drawings. So why the hell am I producing them? They need like 10 data points. How much does it cost? How much quantities? Maybe the complexity of the project. That's what a 3D model would be for. But other than that, they're just trash. There's just trash out the door. CDs, yes, you need all of that information. That's super complex. Again, the way we deliver drawings is super terrible. There's still a chance of change, and that's partially because of all the drudgery that we've been doing. We just never be able to catch up by that time. So I've been thinking about this, of why actually AI is actually hard. So actually there was a, I think it was Andrew posted on LinkedIn. He said, why don't architects document how they actually design, right? And at the same time, around the similar time, Nate Miller wrote something about professional bias. And in my mind, I was thinking, one, it actually is hard. Two, if you've worked for 20 or 30 years, you build an armor of intelligence that it's kind of your secret sauce, and you don't want to give it up. The other reason is they don't know how to decompose why they become that good or why they've come to a discussion. And that's sort of what AI needs. You need the sort of steps in the process and the sort of key aspects or inputs to make why a solution comes out. Now, architecture is harder, engineering is much easier, and I'll talk about that. So this is just a diagram saying that I would say most of the time, what we do as professionals today, 50 to 60%, and I'm being generous, I think, is not actual creative thinking. We're trying to get lines on the drawing. We're trying to get the model look right. We're trying to view something in Revit. We can't figure it out. That's what we're doing. The hope of using AI and building these tools that does the drudgery, at a minimum, is that we can start using our creative and cognitive sort of intelligence. We didn't go to grad school and master's degrees and PhDs, all of that to draw lines on a drawing. So that's the promise, I think, of what AI can do. And in the end, I think we will be the sort of Iron Man of design. And the beauty of that is that, some ideas will come out of these sort of pre-computed solutions or the past data that I was talking about before that we don't have access to. So in 2018, we released Asterisk, and I still think it's super cool software, but we didn't know that we were building ourselves a quagmire of technical debt. But the concept of it was ridiculously good. So it was all machine learning. It was producing a structural design in under a minute, quantifying total square footage, cost per square foot, total weight of structure, as well as embodied energy for steel and concrete buildings. And as Alex mentioned, the problem was that engineers, it was totally black box, 100% black box. So they didn't trust it. They didn't know what was behind it. And that's actually probably the right thing to think, because engineers need to know what's they're engineering. Now, the other problem was this app was meant to be a qualitative engineering app. So it's meant to compare options. As long as those options, they don't, if the options are all relatively correct, it really doesn't matter what the quantities are. It really matters what the differences between those options are. Engineers were not used to doing that at that time. This is, pretty long time ago. So we took the lessons from that, and we built a little Design Explorer interface inside of it. It had all the bells and whistles that you can imagine. I still think it's super cool, but we sunset it because, again, it was hard to manage. So what we learned was it needed to be transparent, it needed to be accurate, it needed to have parity across the different options. We needed to be agile to make updates and changes as needed, customizable, scalable. It needed to have, so we did tall buildings, of course. Yes, we do tall buildings, but it's probably only about 2% of what we do. Most everything's after, so that's probably not a good software product management decision to do something in the 2% versus the 98%. But we wanted, now it's timber, and we wanted all the things that you needed at those early phases. So I'm a little bit obsessed with the cooking analogy. And I like to cook, actually, but I see some real true analogies with what we do as engineers and architects. We want to make that thing. We need the processes in place, or the ingredients, I'll call it, to make good stuff. But if you can't screw up the process of how you actually do it, how you put it together, or if anyone's cooked out there, you do one thing wrong, it doesn't come out right. And so that's why we've been very careful about assembling our machine learning models most recently. So I'll explain how we've gone about it. So, the designers, engineers, and architects, for that matter, want to see that thing, or the options that can go into a building. So what we've done is created machine learning models for almost all the building components in a building with very good accuracy, similar accuracy for all the models. But then, as I mentioned, how hard it's to sort of decompose how the dependencies of a design works. This took the longest time. Kohei's been working on this, and Omid as well. And we're wrapping it in the Shape Tyro platform, which has come a long, long way in the last few years. And again, the diagram doesn't make any sense, other than there's very difficult to sort of connect all of these sort of dependencies, and there's some recursive issues too within a single app. But we're rolling it up into quantities, carbon, and cost. We don't see it here, but also there's the beautification concept. It's like, you actually want to have a good viewer. We don't want like just colors. If you're an architect, or if you're a designer, or if you're an engineer for that matter. So I'm gonna show this version. Oops, how do I go back? Is there a way to click on this? Can you guys click it in the back? Appreciate it. So this is the Shaped Arrow platform. There's sort of the inputs on the left. Engineers love inputs, by the way. And on the right, we're calculating quantities, steel, concrete, and timber, as well as carbon. And so I'll run you through this. Everything that you see in the model is ML, and it's fully dependent. So if we change the wind load, it changes the braces, change the gravity loads, it changes all the floors and the footings and the columns, et cetera. It's all fully sort of wired together. And the beauty of this is, I will say each one of these iterations would take a team of engineers at least a week to do. They would do a probably more accurate job, but does it really matter in schematic design? Not really, actually. Again, my experience as a structural engineer, if you're within 10% either way, it's good enough for SD. And so as you can see, it's all fully connected. We changed the number of stories. It is changing the footings, the columns, et cetera. It's changing the wind load, it's changing the seismic loads because mass is a part of the loading. All of the braced frames and the shear walls that you'll see are hitting performance metrics of drift. And so this is, I'll call it true automation for this level of design. This is brand new. We have micro apps for each one of these elements, but this is the first time we've actually laced it together. You can change wind loads, you can change regions for seismic loading, and it does those loads all in the background. So this is a culmination of like 9 years of work. And will still not be done, obviously. But I think the promise of this is that every engineer could design, in Thornton Tomasetti could design everything that you see, but it just takes them a long time to do it. So they're not learning anything new when they do these things, right? We happen to aggregate everything together, and we are showing true qualitative optioneering so that you can check your carbon, you check your quantities, check your costs, et cetera. So I'm super excited about this. It's kind of limitless of what you can do with this. So we're designing shear walls, et cetera. We're calculating the rebar using ML. It's sort of the reason why I explained my experience, because this is the drudgery that I've went through in the last 30 years that is being automated. And again, as I said, the shape diver platform has come a real long way in being able to sort of produce these visuals, but also the metrics and the graphs. Of course, Dave's plugins are buried in here too. So it's a team effort here. So I'm going to move on. I do think AI will be here, is here to stay. I was really excited. Shajay didn't even mention it because it's kind of a normal thing in his practice, but AI is a normal thing in your practice. I've talked to Luke. It's normal stuff in the practice. There hasn't been a technology that has come around in less than 2 years that becomes normal part of the practice. I'm still in my office training people about what it is, how to use it, how to best use it, et cetera. But it's a process.